Assalamu alaikum. Triangles construction part 3. At the end of this period, students will be able to draw medians and heights, special case obtuse angle, draw bisectors. These are the materials we are going to use. Remarkable lines, medians. The first remarkable lines is the medians. Definition. A median is a segment issued from the vertex to the midpoint of the opposite side. Example, we have triangle ABC. We mark the midpoint of the first side, which is AC. AC is 10 centimeter. So the midpoint of AC is D at 5 centimeter. Now we join the vertex B to the midpoint of its opposite side, which is AC. And then we mark the midpoint of AB. We join E to C. And the midpoint of BC, we join A to F. The intersection point of the three medians is the G. Whenever we are moving the triangle, the intersection point of the three medians doesn't change. So the three medians are always intersecting at the same point. The point of intersection G of the three medians is called the center of gravity or centroid. Steps. 1. Mark the midpoints of each side of the triangle. 2. Join each vertex of the triangle to the midpoint of the opposite side. 3. Mark the point of intersection of the three medians. Note that the three medians meet at one point called the centroid or center of gravity. Application. 1. Draw a triangle MNP such that MN equals 6 cm, NP equals 5 cm, and MP equals 7 cm. 2. Draw PR, the median relative to MN. 3. Find the length of MR. Please pause the video and try to solve the application. Solution. 1 is the figure to the right, triangle MNP with its three sides. 2. Draw PR. Here we have PR is the median relative to MN. When we say median relative to a side, then we have to mark the midpoint of this side and we have to draw the median relative to this side from the vertex opposite to this side, which is P here. P is the vertex opposite to MN, so we draw a median. It is a segment from P to the midpoint of MN, which is R. 3. Find the length of MR. Since R is the midpoint of MN, we have from the given MN equals 6 centimeters, so MR equal 6 divided by 2, which is the 3 centimeter. Remarkable lines, height. Definition. A height is a line issued from a vertex and perpendicular to the opposite side. Example. Using a set square, we put the set square on BC in order to draw the height relative to BC. We put it and we move it till we reach point A. Then we draw a line from A to BC perpendicular to BC. Now we want to draw the height relative to BA. The same way we move the set square till we reach C. We draw a line from C to BA, which is the height. Now the same way also to AC, we draw the height relative to AC. G is the point of intersection of the three heights. The three heights intersect in one point. As we see here, when we move the triangle, the point of intersection, which is the G, in some cases it will be outside the triangle. Why it is outside the triangle? Because we have the case of obtuse triangle. Steps. 1. Using the set square, draw a perpendicular line from each vertex to the opposite side of the triangle. 2. Mark the point of intersection of the three heights. Note that the three heights meet at one point. This point is called the ortho center. Application 1. Draw a triangle PQR such that PQ equals 6 cm, RPQ equal 30 degrees, and RQP equal 100 degrees. 2. Draw the heights of the triangle PQR. 3. Where do the heights meet? Please pause the video and try to solve this application. Solution 1 is the figure to the right. As we see here, RQP angle is 100 degrees. We have one angle in a triangle which is greater than 90 degrees, so this triangle is called obtuse triangle. In the case of obtuse triangle, when we draw the heights, in the second part we draw the heights, where do the heights meet? They meet outside the triangle. So, in case of obtuse triangle, the point of intersection of the heights is outside the triangle. So, here we have first case, obtuse triangle, one of its angles is greater than 90 degrees, then the point of intersection of the three heights is outside the triangle. The ortho center is outside the triangle. In case of acute triangle, when the three angles are less than 90 degrees, in an acute triangle, the ortho center is inside the triangle. In case of right triangle, try to draw a right triangle and draw its heights. You will notice that the three heights meet or intersect on the main vertex of the triangle, which is the right angled vertex. So in a right triangle, the ortho center is at the vertex of the right angle. Application. Given ABC is a triangle with angle ACB equal 55 degrees. 1. Draw BH, the height relative to AC. 2. Find the measure of BHC and HBC. Please pause the video and try to solve this application. Solution. The first part is the figure to the right. You have any triangle ABC such that the angle ACB is equal to 55 degrees. Part 2. Find the measure of BHC first. BHC. Since BH is the height relative to AC, then H is the foot of the height relative to AC. Then BHC is a right angle. It is equal to 90 degrees. Now we have to find the measure of HBC. HBC, this angle. We have in triangle HBC, angle C is equal to 55 degrees by given, and angle H is equal to 90 degrees. We just find it. Now to find angle B, we know that the sum of angles in any triangle is equal to 180 degrees. Then 180 degrees minus 90 degrees plus 55 degrees, which is 180 degrees minus 145 degrees, 35 degrees. HBC is equal to 35 degrees. Third case in remarkable lines, bisector of an angle. We will learn how to draw the bisectors of angles inside a triangle. Definition. A bisector of an angle is a semi-line that divides the angle into two equal angles. Example. In order to draw the bisectors of angles, we can use the compass or the protractor. To use the compass, first, we want to draw the bisector of angle ABC. So we put the sharp end of the compass on B. We make an arc on AB, then the same opening, we make another arc on BC. We don't change the opening of the compass. Then we put another time the sharp end of the compass on the intersection point of the side AB and the arc, the first arc, and we draw another arc outside the triangle. Then we put the sharp end of the compass also on the point of intersection of BC and the arc on BC, and we draw another arc outside the triangle. We put the point of intersection of the two arcs, Now we have the bisector of the first angle, which is B. We will use now the protractor to find the bisector of angle C. Simply, we have the protractor, we measure the angle C and we divide it into 2. Then we measure the angle A and we divide the angle into 2, and then we draw the bisector. The 3 bisectors will meet at one point. This point is inside the triangle. Whenever we are moving the triangle or changing the size of the triangle, the point is always inside the triangle and the bisectors always meet at one point. Steps 1. Using the protractor or compass, we divide the angle into 2 equal angles and we extend the line to the opposite side of the triangle. 2. Locate the point of intersection of the 3 bisectors. The 3 bisectors meet at one point called the end center. Application 1. Draw a triangle LMN such that MN equal 5 cm, NL equal 6 cm, and MNL equal 50 degrees. 2. Draw the bisectors of triangle LMN. Please pause the video and try to solve this application. Solution. Here we have the triangle LMN. Angle N is equal to 50 degrees, NL is equal to 6 cm, and MN is equal to 5 cm. Can you remember which method do we use in order to draw this triangle? Yes, we use the method of side angle side. Now, in order to draw the bisectors of triangle LMN, we have 2 methods, using the protractor or using the compass. We divide each angle into 2 equal angles using a semi-line. The point of intersection of the 3 bisectors is called the end center. Assignment: review page 132, part 2, bisectors and heights, page 133, part 3A from the textbook. Homework: exercises 14, 15, and 19, pages 136 and 137 on the textbook. Summary: kinds of triangles. We have isosceles, right isosceles and equilateral triangle, right, acute, obtuse, and scalene triangle. Remarkable lines. We have 3 remarkable lines. Medians, their point of intersection is the center of gravity. Heights, their point of intersection is called the ortho center, and bisectors, their point of intersection is called the end center. Construction: first we have to know that the sum of measure of any 2 sides is greater than the third, triangle inequality. First case of construction: construct a triangle knowing the measures of the 3 sides, side, side, side. Construct a triangle knowing the measure of 2 sides and the angle included between the 2 sides, side, angle, side. Construct a triangle knowing the measure of 1 side and the adjacent angles to this side, angle, side, angle. Thank you for your attention.